In this video, I'll be handling the likely questions that we will encounter. I'm going to handle 6 likely questions for titration, and I'll solve all of them. You will see the questions on the screen. So likely questions, and then their solutions. So the likely questions on titrations. So this will cover everything. Like in titration, what are the calculations we are expecting? We will calculate something involving finding the molar mass of the acid, finding the molar mass of the base, finding the atomic number of the metal in a base, or even finding the unknown anion attached to an acid, then percentage purity, then water crystallization, finding mole ratio of the acids. These are the possible calculations. Then being able to calculate the number of moles of hydrogen ion, the number of moles of salt, the number of carbon dioxide used, the molarity, the dilution laws. So these are the things. So the question is carefully crafted to cover the majority of the expected fields. So in this year's WAEC, we'll be expecting these calculations. So I'll go straight to question number 1. And beside, I'll be using in this calculation is my endpoint or my VA. I'll be using 25.10 cm cube. That's what I'll be using throughout the whole examples, okay? Throughout the likely questions. Your job is to understand how I'm solving it and why I'm doing whatever I'm doing. Please don't memorize, understand. Feel free to ask questions down there in the comment section, okay? Now we move with the likely question number 1. As you can see down the screen, it says that A is a solution of HCl. Just screenshot it and move straight to the solving, but I'll still need those information. Now what you need to do while solving anyone is how to make your table. That's I have a different video for that, or maybe I'll still teach that here. To make your table, remember to make table with a pen. Don't make with pencil. Don't write any part of the exam with pencil for chemistry, especially your table. Endeavor not to cancel your table, okay? So this one is made for just we call this place burette readings. The burette readings. Then we have final, initial, and then volume of A used. Now rule, then here I'll do at least 3 titrations. Here should be our rough. You can put unit here or here. You can put cm cube here, or you put cm cube here. Let there be unit. First titration, all in cm cube. Second titration. This is the least possible you can do. You cannot do rough and first and stop. No. Rather, most times we do first, second, and third. But I'm making this faster. So the initial, your rough, maybe in this case we have, maybe I'll have 26.20. Remember that the endpoint your school teacher arrives after titration is what determines if you are right or wrong. Not this one I'm using here, for students anyway. So here 26.20 minus 0.00 will give us 26.20. okay, then this one is maybe I want to use the exact thing I got, 24.90, and then 25.10. okay, if I end up like this, everything here 0.00, 24.90, then here 0.00, 25.10. So you will determine your average. Remember to use concordant titers, which means your values should not vary with more than plus or minus 0.2. The difference between 24.90 and 25.10 is just 0.2. So it is concordant. We call them concordant titer. Therefore, my average, meaning average volume of A used, average volume of A equal to, is also good if you tell the marker first plus second. If you use 2, you divide by 2. Then in another line, you now say, you will say first divide by second divide by 2. You now say 24.9. I'm cleaning up this because no space. I will interpret what is the first, which is 24.9 plus what? 25.1 all over what? 2. So when we calculate this, we will have that definitely we are going to get in the middle, which is 25.0. Well, let me still confirm. That means I will be using 25.0 here. So we have 24.90 plus 25.1, which is 50 divided by 2. Is equal to 25. So 25.00 cm cube. Remember to obey this. That's just by the way. That means here I will be using 25.00. Then always indicate on the table volume of a pipette used. Watch my video that says lose 20 marks if you don't do this. That gives you guideline on WAEC marking scheme. Okay? Or you join my live stream. That will happen a day before the final exam for you to get other precautions, which will be very important class. Okay. All right. So we have seen the likely questions. Because of space, I will clean up this. Likely question 1. What matters is that in whichever way, whatever you are doing, make sure you bring out these informations now in the exam. Look at the basic information you will not forget to bring out. See what they said A is. Write it out. What did they say B is? Write it out. So that's very important. In this likely question 1 in titration, we have that A is just HCl. They didn't give us further information. So you also write it. A is just a solution of what? HCl. No strength. While B is a solution, but it is 2 grams in what? In 250 cm cube of what? Solution of NaHCO3. These are the basic things. You keep it aside. Now, other things to tabulate your direct shooting, which is what I've answered. That's going to be the same thing. That table I made will be the same thing for all those other likely questions. So we have that the equation of the reaction, they gave it to us, which you can see there on the screen. HCl plus NaOH. Okay, let me still write it. HCl plus NaHCO3 to give sodium chloride plus water plus CO2. Okay, so this is balanced such that we have 1:1. Then I say we have done question 1A, which is put A in a burette and titrate again 2025, which is that table I made. Writing 25 as your volume of pipette used on top of your table. If your school is using 25.00, if your school is using 20, write 20. It depends on your teacher and the management of the school, what volume they want to use. So from the B part of it says, from your results and the information provided, calculate the molarity of B. Looking at this molarity of B, look at what B is. They give us gram, and we have 2 types of concentrations as far as this is concerned, which are mass concentration and what? Molar concentrations. So these are the 2 concentrations we have. And mass concentration is gram per dm cube, while molar concentration is mole per dm cube. Molar, mass, gram, that's how to know it, okay? Now, there is a relation that connects these 2, which says that mole per dm cube is equal to gram per dm cube all over gram per mole, meaning that molarity, we can also call this mole per dm cube molarity. Molarity is equal to mass concentration all over molar mass. mass concentration all over molar mass. And they are now asking us to find the molarity of B, and B is sodium triazocarbonate 4. You first of all find the molar mass of sodium triazocarbonate 4. What's the molar mass? Sodium is 23, it is given there, plus hydrogen is 1, plus carbon is 12, plus oxygen is 16 times 3, which is 48. If you sum up all this, you arrive at 84 grams per mole. That means that 1 mole of this is 84. Now, they told us 2 grams in 250, but this says mass concentration is gram in dm cube, and 1 dm cube is equal to 1000 cm cube. The concentration did not say, mass concentration is not the amount in 250, rather they say the mass in 1 dm cube, which means mass in 1000 cm cube, but we have 250. So if not in 1000, find out the one in 1000. That is how to solve this. If not in 1000, find out the one in 1000. Okay, so, and this is not in 1000 cm cube, therefore I will say if what, if 250, which is the volume given to you, contains 2 grams, what will 1000, looking at this, 250 gave 2 grams, 1000 will give x. That means you cross multiply. When you cross multiply, you have that 250x will give you 2 times 1000, which is the same thing as that 250x is equal to 2000, such that x alone is now 2000 divided by 250. So this is where you can now use the generalization of the formula, which says that gram per dm cube is equal to 1000 times mass given all over volume given. 1000 times mass given all over volume given. So at the end, if you say 2000 divided by 250, it will give us 8 grams per dm cube. So this is the mass concentration. But remember, they told us to find the molarity. So we have gotten the gram per dm cube. What do? We now come back. We have gotten the gram per dm cube. What do we do now? We now come back and convert as usual. Look at the formula that connects mole per dm cube with gram per dm cube. We have already known molar mass. Gram per mole is 84, and the mole per dm cube unknown, but the gram per dm cube is now 8. So the next thing is to convert mass concentration to molar concentration. Okay, to achieve this, we have that 2 values here. Don't need of making, so we are looking for mole per dm cube. We just say gram per dm cube over gram per mole. Okay, we know mole, we don't know mole per dm cube. We have seen gram per dm cube and gram per mole. Simple. So our mole per dm cube, that's molarity, is now equal to gram per dm cube we got was 8. What's the gram per mole? 84 divided by 84. So 8 divided by 84 is 0.095. 0.095. So 0.095 mole. Remember to put correct unit. So you are allowed to make the 0.1 depending on how they give you your values in the question. Okay, so but if the question, if they have told us that a is 0.0 maybe 5, we are going to leave it at that 0.1, because if you want to keep to this. But if they say 0.015, we will keep it at 0.095. I seen it now, 3 decimal places, and most times you obey 3 significant figures, so you can leave it this way. That is your C, what? That's your CB. We have gotten our CB, that's molarity. So know it today, concentration of B in mole per dm cube is equal to 0.095 mole per dm cube. So going to the next question, we are required to also calculate, that's question 1B. The 1B says we are also required to calculate concentration of A in mole per dm cube. Concentration of A in mole per dm cube. Remember, this A, they just said is HCl, so no information about that. So concentration of, we are solving 1BIR. Concentration of A in mole per dm cube. This is where you have to apply the formula. My students funnily call it Carver formula. Ca Va over Cb Vb equals Na over Nb. Okay, so the one thing we need to know about this formula is that all the concentrations must be in mole per dm cube. I told you we have two concentrations, two forms for now, although we have other forms. We have weight by volume, volume by weight, molarity, normality, molality, molarity. It seems I'm saying the same thing, but I think I repeated molarity twice. Molarity, normality, weight by volume, volume by volume, weight by weight, percentages. But for now, we are going to concentrate only on two, the mole per dm cube and the gram per dm cube. So this C is concentration, V is volume, C concentration, V volume. B here stands for the base and A stands for the acid, okay? But the concentration here must be mole per dm cube, like 2 gram in 250. I cannot put these two as my CB, no, because it's in grams. And it must be in dm cube. That time I got 8 grams. I cannot put 8 here, rather I'll put the mole, which means my CB that will suit here is 0.095. What I'm trying to say is that when they give you CB in gram per dm cube and you can't access the mole per dm cube, you can't use this formula. All the concentration here must be in mole per dm cube. So, and they told us to find the concentration of A in mole per dm cube, and that is Ca. What you don't want to do is to fix the whole values. No, before you fix, you make the unknown the one what you are looking for subject to the formula. So Ca here is equal to Cb what? VbNa all over what? VaNb. Alright? So when you look at this, what will it be? It will be, we now start fixing values. What is our Cb? That is 0.095 we got earlier. What's our Vb? The volume of base, 25. That's the volume of pipette. What's our Na? The mole ratio of the acid. That's the HCl from the balanced chemical equation is 1. The mole ratio of acid to base is 1:1 times 1 all over Va. It is still my endpoint, which I got as 25 times Nb here is 1. So this is simple. 25 cancel 25. So at the end, Ca will still be equal to Cb. Reason is because their volumes are equal and the mole ratios are the same. So they have to be equal also. You say Ca mole per dm cube. Remember to put units. This is our final answer. Then the next is question 1 BIII. That's what it tells us. Told us to find the mass of B in the mass of A in 250 cm cube of solution A. The mass of A in 250 cm cube of solution A. Okay. The mass of A in 250 cm cube of solution A. So we move to BII. Mass of A in 250 cm cube of solution A. We now go by what is the molarity of A. Ca we got 0.095 moles per dm cube. That means how many moles are in 1 dm cube? So we have to find the equivalent mole that is in this given volume. Alright, so the equivalent mole should now be, we interpret this as 1 dm cube is equal to 1000 cm cube, which contains 0.095. Okay, anytime you see this dm cube, interpret it as 1000 cm cube, because they will always give you volume in cm cube. So what do we now say? The volume we are looking for is 250. So in an exam, if they say 25, use 25. If they say 50 here, use it. This is a guide to teach you how to calculate. 250 will contain x. You cross multiply 1000, x is equal to 250 times 0.095. We now say divide both sides by 1000, divide both sides by 1000. So you cancel, so which implies that this can go to itself and this becomes 1. So 0.095, sorry, divided by 4 will give us 0.024. Okay, this will give us 0.024 times 0.024 moles, 0.024 moles of what? Of HCl. Therefore, we convert back to mass. They ask us the mass. So how do we convert back to mass? We have gotten mole. We can now use the formula which says that mole is equal to mass over molar mass. And the molar mass of HCl is 36.5. Hydrogen is 1, chlorine is 35.5. 1 plus 35.5 is 36.5. Therefore, our mole N is already 0.024. So 0.024 is equal to the mass we are looking for, all over 36.5. Cross multiply, find out that mass is 0.024 times what? 36.5. So in this case, what is our answer? We will get something like 0.87 gram as the mass of HCl. Okay. The next question says the volume of carbon 4 oxide liberated from the titration reaction. The volume of carbon 4 oxide liberated from the titration reaction at STP. So the volume liberated at STP the volume of carbon 4 oxide liberated at STP, that's 1BIV. 1BIV. We are looking for what? Volume of CO2 liberated from the reaction at what? We should know they gave us the volume occupied by a gas at STP is 22.4 dm3. Now from the equation we have to write back the equation of the reaction. Sodium hydrogen thiazocarbonate 4 plus HCl will give us what? Will give us sodium chloride plus water plus CO2. So this is the equation. Now what is liberating the CO2 is this. You can relate this to this, meaning the thiazocarbonate is hydrogen thiazocarbonate liberates CO2, and from balanced chemical equation the mole ratio of the thiazocarbonate to CO2 is 1, is here. 1 mole NaHCO3 is equal to what? 1 mole CO2 gas, right? So this is mole. Remember, if you balance the equation and 2 is here, I'll write 2 more. And if 3 is here, I'll write 3. If 4 is here, I'll write, but there is 1. The coefficient here is 1. Now, you go back to find out the CB. From our concept, what's the concentration of this B? Which is 0.095 mole per dm cube. Okay? And this implies that they said from the reaction. Okay? This also implies that if 1 mole will give us 1 mole of this, automatically it implies that 1 mole will liberate 22.4, because 1 mole of any gas at STP is 22.4. But in the reaction, remember class, we did not use the whole B. We did not use the whole 1000. It is when we use about 1 liter, which is 1000 cm cube, that we'll be able to consume 0.095 moles of that B. But unfortunately, we used in the titration. What was the volume of B used? 25. So out of the whole thing provided, we on the average use 25. So you are going to now say 1000, because of this dm cube, contains what? 0.095. Now 25, which is the volume we used. In exam, if they specify it, they might tell you what volume of carbon 4 oxide is liberated by 500 cm cube of B. You now use 500 here, but the question says from the reaction, and from the reaction we use 25. So 25 cm cube will give what? X. So you cross multiply. 1000 X is equal to 25 times 0.095. Divide both sides by 1000. Divide both sides by 1000 to cancel, so that X stands alone. So X is now 25 times 0.095 all by 1000. It's going to give us a small value of 0.0 something. So from the calculator side, we have 0 to 25 times 0.095 divide by 1000. 1, 2, 3. 0.00237. I'll make it 0.0024. 0.0024. Am I right? Yeah. 0.0024 what? Moles. That's the mole we use up in the reaction. You now go back to the equation of the reaction, which is telling us that 1 mole of NaCO, because there is coefficient here, NaHCO3 will give us 1 mole of CO2. Therefore, we come back here now and say 1 mole of NaC, 1 mole of this will liberate what? 1 mole of CO2, but we are looking for it in volume, 22.4 dm³, right? Then what with 0. What? This is in moles, so 0.0024 moles liberate. We liberate now X, such that X is equal to now 22 cross multiply 0.4 times 0.0024, right? So from the calculator department we have, let me multiply without, times 22.4 is equal to 0.053. 0.053 what? The unit is a dm cube, because they asked us volume. This is our answer for question 1B IV. Okay, so we go now to the likely question 2. I will leave that 2 for the live stream. You try to join. I'm going to the likely question 3 now, which is they gave us the whole grammar. This time around we are going to change. Remember, your job is to note the information given to you about the A and B. So we go to next question. The information about A and B changes now. Copy out. Remember to follow strictly the values given to you in the question paper. No matter whatever I'm using here or whatever your teacher might have used, look at the question paper and solve according to the values given to you there, please. Don't approximate the values given to you in the question paper. Like if they give you 0.05, don't make it 0.1, okay? Use it as 0.05, exactly the way they gave it to you. Now, likely question 2. What is the basic information? I will go to likely question 3, like I said, which says HCl. A is, we write it as somewhere, 0.1 mole HCl. Simple. 0.1 mole per dm³ HCl, which means that's the standard solution, is of known concentration, HCl. Alright. Then B, the question 3 told us that B is a solution of XH. B is a solution of XHCO3. So nothing is given about B, they just mentioned it. So we now go and do our titrations. Use the same table I used for likely question 1. That is the same table because it's the same reagent, but these are possible questions that can be reconstructed. Now I've hidden the metal attached to the substance, the analytes acting as the base. So let's try finding what X is. Like I told you in the beginning, these are the uses of titration. So to teach you the possible things. So your job is to understand very well. The question 3, 3A is automatically answered. That is the table I already made. So 3BI says, from your say information, calculate the concentration of B in mole per dm³. So BI, concentration of B in what? Mole per dm what? Cube. Concentration of B in mole per dm³. Is that clear? So concentration of B in mole per dm³, looking at the information provided, when they ask you for concentration, you reconsider using 2 formula, which is the 2 formulas that you might use is the one I gave you in the beginning. Mole per dm³ is equal to gram per dm³ all over what? Gram per mole. Or if you like, molarity is equal to mass concentration all over molar mass. Molarity is equal to what? Mass concentration all over molar mass. So these are the things you are expected to know. For you to use this, let's try applying this in this case. What is our mole per dm³? That's what we are looking for B. What is our gram per dm³? Is unknown, it was not given. We are just told that B is XHCO3 solution. Then what's the gram per mole of B? We don't know that also. That's the molar mass. We can't calculate because X is unknown, even though we know that H is 1, carbon is 12, oxygen. So because of this X, we don't know the molar mass. So we have two unknowns. And if you have two unknowns, that means this formula will not work. In exam, nobody will tell you, look at the formula to use. You figure it out by this thing I'm doing now. When you do this, you find out which one am I going to go with, okay? When you find the one you are going to go with, you go, it means this one is not working. Immediately this one is not working. You go to what? CAVA all over CBVB. So the next thing that will work out is the Carver formula, CAVA all over CBVB equals NA over NB. So by so doing, we are looking for CB. That means every other thing here is already known. So like I told you, your job first is to make the unknown subject, the one you are looking for, the subject of the formula. So CB here, remember, we'll cross multiply. Use this and multiply this, use this and multiply this. So mathematically, let me do it just once. I won't repeat because this is no mass. Cross multiply. CBV because they equal to CAVANB. You cross multiply. Now divide both sides by everything around CB that is not CB, and that is VBNA, yeah, then VBNA. So that is our CB is equal to CAVANB over VBNA. We substitute what is our CA, it was given direct 0.1. Then what's our VA? That's the end point. That's volume of acid. That's your end point. We're using 25 here. Remember, it's not all about forging so that you rhyme at what X really mean. We all know that X is sodium and we're expected to get 23. But that doesn't mean that if you don't get 23 in the exam that you have failed. What is marked is your steps. I'm speaking from experience. Your steps and your calculation, because end point will change everything. And shockingly, in exam, WAEC or NECO might come and give you the different value from what they told you, your teachers, to prepare. Like the HCA is about 0.1 mole, fine. They can decide to make it 0.2. You will see it in some of my likely questions. Don't quarrel with them. Use 0.2. If you do that, you now see that your value will either be multiplied by 2 or will be halved. So they are marking your steps. So even if you don't get X as 23 towards the end, that doesn't mean you have failed. What is failing you is the way you solve your mathematics, arithmetic error. Are you obeying the steps? Are you making your subjects of the formula where necessary? Are you putting units when you get the final answer? Do you get me now? So don't bother about forging. So that you don't go being afraid. I did not get 23, so I failed. It's not true. Who told you that thing is sodium? You never knew. And have you gotten the like? Do you know how many years it will take you to do analysis accurately and get the real thing? I know how many years it took me. So what it means now is that if you hide it for me, I'll tell you that what is in that sample is sodium. But you needed high accuracy and frequent practice. Okay. Now let's move on. 0.1 times 25 times 1. Why use 1? Because NB, mole ratio of acid and base, there is 1:1. Then divide by what? 25 is VB also times 1. So this is very easy to do now. So our CB will still be the same thing because this is 25 divided by 25. You cancel that, so that CB will still rhyme as the same thing as what? CA. So remember to write mole per dm cube. I warn again, your own must not be, if your endpoint is not 25, your CB cannot be CA again, exactly. So, but keep working with that value. So my CB now is 0.1, all right? Mole per dm cube. We go to the next question. In question 3, BII, which says concentration of B in gram per dm cube. Concentration of what? B in gram per dm cube. From solving, we will check if it is possible. Concentration of B in gram per dm cube. Okay. Concentration of B in gram per dm cube. That will not be possible. It's okay. When we solve, you see the error in the question we asked. Why concentration of B in gram per dm cube will not be possible here is that we don't know the molar mass already, and we don't also know the mass, so we can't be working with two unknowns. Okay, So that means I supposed to have given that gram per dm cube, please. So the question will be reconstructed. Question number 3, concentration of B in gram per dm cube. We are going to say that B is the correct thing that will be there is that B is let's say that B is a solution containing 8 grams per dm cube XHCO3. I will modify that question just now that I saw it before solving. Okay, that is before, as you'll be watching this is already modified. I will modify it before pasting it. Now, if this is the possibility, okay, that's why we solve question before releasing, because to you might think it's correct until you start solving, you see the problems associated with it. And sometimes WAEC do that mistake. You'll be asking, did they solve this? Even in SWOT analysis, most times say, did the person asking this question, did the person try doing it, or you just sat down and assumed theoretically? That's the worst thing that kills Africa. I already know it. CO2, tons, lime, water, milky. And your mixtures, you have not even checked whether it is possible. Just like in this SWOT analysis, we have some strange observations when you're analyzing mixture of glucose and copper tetraoxide 6. There are strange things that will happen, and definitely where I could still come from that strange confusion with that, because if even me, I assumed the incorrect thing. But when I did it, I was shocked. Say, until now, if I don't do it, I will not know, just like what we are seeing now. So please, the correct thing should be that B is 8 grams per dm cube XHCO3, so that we can now solve for molar mass of B. So the next question that is possible is to find the molar mass of B. All right, to find the molar mass of B. Molar mass of B. So the next one is the III, which we will look at molar mass of B. So we will now use the formula that contains molar mass, and the formula is that molarity is equal to what? Mass concentration all over what? Molar mass. And our molar mass is what we don't know. So molar mass here, make it subject to the formula, is automatically what? Mass concentration all over molarity. That's molarity is the mole per dm cube. And from our calculation, we have already gotten the mole per dm cube of B, which is 0.1. And what is the mass concentration, which is 8 grams. So you can now say that molar mass of B is equal to, you substitute values, 8 over 0.1. And if you do this, 8 over 0.1 is automatically giving you 80 grams per dm cube. Okay, remember I use 0.1 here, and that endpoint is, so I will not be arriving at that 84, you know, but there is no crime at all. So 8 over 0.1 is 80, of course I know, 80 gram per mole. Remember, it's going to be per mole because we are looking for, that's the unit for molar mass, gram per mole. While the unit for mass concentration is gram per dm cube, the unit for molarity is mole per dm cube. All right. So we have now 80 gram per mole. Please put it to give you your score. This is it. The next question that follows it now is to find the what? Find the value of X. They say calculate the relative atomic mass of what? X. So we will calculate the relative atomic mass of X. How do we do that? The relative atomic mass of X in this compound. We already know that B is now XHCO3. That means the molar mass is 80. That these things were summed up and gave us 80. This implies that X plus H plus C plus 3 times oxygen we sum up. This is not 3 times 0 before you get it twisted. Oxygen times 3, not 0, will give us 80. We already know what hydrogen is. It's given to us as 1. So X plus 1 plus 12 is 13 plus 60 watts plus 48 automatically gives us CO3 itself is 60. So we are looking at 61 if I'm correct. So but let's just do it. 1 plus 12 plus 48. This is 13, and if you put it here, it's going to be 61. Put 13 here. 8 plus 3 is 11. Then 4 plus 1 is 5 plus the other one, so it's going to be 61, sorry. So 6x plus 61 equal to 80, such that x is equal to 80 minus 61, such that our x will now give us 19. If I'm not mistaken, that will give us 19. There is no unit since they say relative atomic mass, or you can say AMU, atomic mass unit. So 19 is our answer. Don't go struggling that sodium is 23 and we didn't end up with 23. No, it's your mathematics that really matters. Okay, so the basic information given is that A contains 3.65 grams. A, write it out somewhere, 3.65 grams of 3.65 grams per dm cube, 0.65 grams of HX. Then now I heated the chlorine is possible in 500 cm cube. Remember not to correct the question, just solve according to the values given to you. Then B, I corrected my own because I'm the one that constructed the question that it was faulty from solving. Okay, then B is 0.1 mole per dm cube sodium carbonate. It's possible they purposely changed that hydrogen carbonate to carbonate. There's no crime about that. It doesn't concern you. Just follow what they said. 0.01, because they can even change the HCl to HNO3. I'm speaking from experience. They do it. That doesn't mean you go and force them. Use whatever you see in that question paper. As a student, remember you are not allowed to hear or see anything that the teacher has prepared. So it's a secret. Are you a prophet? So use it exactly. I decided to set it this way. It wasn't an error. Na2CO3. I know what I did, just to give you confidence that they can decide to change that thing. They might even change it with what? Potassium hydrogen triazocarbonate 4. It is possible that way. Is the calculation that they are marking. Whether they change it or not, your endpoint never changes because the teacher has already prepared the reagents ahead. The teacher cannot come inside the hall and go and change sodium to potassium. So your endpoint remains unchanged no matter how the question changes. Because some of you enter into the examination hall because you are inexperienced and start adjusting your endpoint to suit what the question paper. It's not true. What endpoints depends on is how you, the student, or how you and the teacher rhymes with your student. How far are they from your value? You are the one judging your student. That value you put down in your report is what is used to mark your student. So forget about these manipulations. I know some may not understand this thing I'm saying, but that's the reality. Okay, so bear in mind that they can change A and B to anything they like, especially when it's monobasic. They will still use another monobasic acid. They can still use this. Okay, now 0.1 mole per dm cube sodium triazocarbonate 4. They now give us equation. After everything, put B. Remember, you use the same table. The equation of the reaction according to them is 2HX according to Misha to give plus Na2CO3. It is not a mistake to give us what? To give us what is that question self? Okay, I'm supposed to write it even off head. NaX plus water plus CO2, but to balance the equation, sodium is 2 here, we need to put 2 here, and when we put 2 here, that's why the 2 is here, because X is now 2. So in this case, the difference is that the mole ratio of acid to base becomes now 2:1. Alright, so that 2:1 holds it. 2:1 is to 2 is to 1 is to 1. Do you understand? Now we go ahead and see what 4b said. 4bi is a concentration of A in mole per dm cube. So concentration of A in mole per dm cube. We now try again. Can we use mole per dm cube equal to gram per dm cube all over gram per mole? Is it possible here? Check. What is the information about A? 3.65 gram per dm. That's the mass concentration, which is supposed to be here. Very correct. Then what's the molar mass of HX? Don't claim you already know it's HCl when the X is hidden. You don't know. So it means that we don't know molar mass because X, remember this X can be Y or any other letter, is unknown. So we cannot use this formula because we don't know this and we don't know this. This is what they told us to calculate. So we can't solve simultaneous equation here. Anytime two of these three is unknown, it means you cannot use it. And what did I say? If this formula did not work for concentration, we move straight to CAVA all over CBVB equals NA over NB. Right? So we start solving immediately. CA is equal to CBVB NA over what? Over VANB. We start substituting value. What is our B? They gave it to us 0.1 times. Remember that this HX was in 500. Don't joke with this volume. That means it is not even 3.65 that is the mass conc. We will find the one in 1000. Be careful. The questions are constructed to teach you the possible things. Okay, that you might see. VB is our 25 times NA here. Now be careful. NA is 2, mole ratio of the acid, times 2 this time around. Divide by VA is still our endpoint, which is 25. Remember to use the endpoint. If you are using 26 point whatever, 25.7, put it here. Times NB is do your titration if your school is not so much compromised. Because normal thing is that teachers, I don't release it to my students. Endpoint should not, it is a secret, but I'll teach you well. Okay, 25 times depending on the training I've given them, because I train them well. Not when you don't train your own, you say you not give them, times 1, because NB is 1. So in this case, it is no more cancel because 25 can cancel 25, but what happens to the 2? It becomes 0.2. The answer now is 0.2. Cancel. So it remains now 0.1 times 2. So the molarity is 0.2 what? Mole per dm cube. Answer, that's the CA concentration of HX in this case, even though what they provided is 0.1. But that day it's possible you can see any strength. Please use that strength provided for you. So this is our answer. We go to now 3BII. We are required to solve the question. 3BII says, are we still in 3B? 4B, sorry, 4BII. Don't mind me, 4BII. We have solved this already. 4BII says the molar mass of HX. See, this one is well constructed. The molar mass of HX. This is well constructed. More than the other one, I made a mistake. Molar mass of what? HX. This is where you now apply your mole per dm cube is equal to what? Gram per dm cube all over gram per mole. We are looking for gram per mole because they say molar mass. In that case, subject to the formula necessary, gram per mole is now equal to gram per dm cube all over mole per dm cube. That is what it implies. Okay, let me keep one style. We will have to find out our what? Gram per dm cube. It is not 3.65. Why? Because they said in 500. You use 3.65 in your exam if they said it's in 1 dm cube or 1000 cm cube. Remember that 1000 cm cube is equal to 1.0 dm cube. So if they give you strength inside these volumes of solution, use it. That's the correct concentration. But when not inside 1000 or 1.0 dm cube, find out the one here. Even when it is in 2000, find out the one in 1000. That's the correct answer. Here we said 500. So to find the correct mass concentration, what will it be? That's the correct thing we'll put here. Mass conc will now be equal to what? You say 500 contains what? According to the statement, 3.65 grams. Whatever 1000 cm cube contains should be our answer. Automatically, X will now contain what? 3.6 what? 5 times what? 1000 divided by 500. And if you do this, this becomes 1, this becomes 2. So our answer will be around 7 point something, 3.6. Please, this is 3.65, not 665. 3.65 times 2, 7 point what? equal to 7.3. 7.3. So we have 7.3 what? Gram per dm cube. We have not gotten an answer. We are just trying to find this value. So that is the mass concentration. We can now move ahead to find the molar mass of the solution A. The molar mass of solution A automatically becomes, substitute values immediately. Gram per mole, gram per dm cube. We have already gotten gram per dm cube as now 7.3. So let's go. So the gram per mole is equal to 7.3 all over. The mole per dm cube we got was 0.2. So 7.3 divided by 0.2 will give us what? Which is still 36.5. 7.3 divided by 0.2 is equal to 36.5 still. So we have landed in what? The molar mass is 36.5 gram per mole. This is our answer for that question. We now go further. They will now tell us to find X still, just like we did. The other question says find the relative what? Atomic mass of X. We now go back to know what X is. Is Hx already? So 4b I says relative atomic mass of X. Already A is Hx, which we find the total mass of H and X to be 36.5 grams. So it means hydrogen is 1, we already know. So 1 plus X is equal to 36.5, such that X is now 36.5 minus 1. So X is equal to 35.5. Don't bother if you are not rhyming with 35.5, which rhymes with what chlorine is. So you rhyming like this depends on the value the examiner decides to give you. So they might purposely give you a value that will not allow you to get that thing. Exactly. Alright, so the next question says the number of gas molecules evolved from the reaction. This time around, number of gas molecules evolved from the reaction. Okay. Number of gas molecules evolved from the reaction. So for BIV, number of molecules of gas evolved. The only gas evolved there is CO2 from the reaction. Evolved from the reaction. Okay. So you have to write the equation of the reaction, which is Hx, repeat again to help you, plus Na2CO3 to give us NaX plus H2O plus CO2. Anytime acid reacts with carbonate, it produces a salt of the metal, and water and CO2 is compulsory. Then look at the gas. This is the only gas form. They will show you to the states of matter. This is liquid, this is aqueous, this is aqueous. Okay, so what do we do next? Balance the equation, put 2 here and put 2 here. So we are looking at molecules now. So we have to find the unit that connects particles, which is Avogadro's number. So 1 mole of any substance contains Avogadro's number. So we now go by from the reaction. Remember they say from the reaction, like what I solved earlier. We did not, if you like you use this, if you like you use Hx. We did not use the whole 1000 cm cube. Remember, it is the VA that we use here, and this is VB 25. They happen to be 25 according to what I'm solving here. So we can use any of them and get an answer. So we can say 2 moles Hx will give us 1 mole CO2, and this implies that 2 moles Hx automatically will liberate 6.02 times 10 raised to the power 23 molecules of CO2. We now go back and find the real molecule we used from the reaction by using Ca is equal to what our Ca 0.1. That's what we got as our answer, and this 0.1 means the amount in 1000. Okay, this is simple. And what is the Va? Va was 25.00. That's your end point. You now say 0.1 is in 1000. This means that 1000 contains what? 0.1. What will 25 contain? Call it x. 25 will now contain what? To contain automatically, x will now be equal to 0.1 times 25 all over 1000 after doing the solved of the formula. So 2.5 divided by 1000 will be our answer, because 0.1 times 25 is 2.5. So we have 0.0025 what? Moles. That's the mole we use. Okay, we can now come back and say, I think I'm permitted to clean off 0.0025. we need it. We now come back from the equation. We have that 2 moles HCl contains 6.02 times 10 raised to the power 20. Remember, if there is 2 behind that CO2 in the equation, we times this thing by 2. So how many molecules will be in 0.025 moles of the same HCl? So we call here x, such that cross multiply 2x is now equal to 6.02 times 10 raised to the power 23 times 0.0025. So we divide everything by 2 to make x the subject of the formula. So by so doing, we can minimize our efforts by dividing this one by 2 by 2. So if we divide this, it becomes 3.01. 0.2 divided by 2 is still 0.1 times 10 raised to the power 23 remains, then times 0.0025. Okay, whatever it gives you is the final answer. Don't have time pressing the exponent. Okay, it now remain question 5 and 6. Please subscribe to this new channel, this majestic tutorial. I cannot do without you helping me to expand. I created this channel to handle theoretical works, teachings, while the other channels, Her Majesty's World Science channel, will stand for practicals. So like as you can see, I'll do the experiment, or I've done the experiment on this titration as Her Majesty's World, but here I'm now doing the calculations. So I discovered that most of us don't like science, or get the other one and get the other one separately. That channel was built mainly for science, but I discovered people love certificates more than science. It looks like when I upload experiments, it's a distraction, like most of them. They skip it. So let's come here. If you need experiments, you go to the other side. Please help me grow this young channel. I cannot do if you don't share or subscribe. Thank you.